All right, Algebra 1B students, welcome to part 3 of lesson 9-7, where we are deciding between linear, exponential, and quadratic functions. Today's video, we are going to do exactly the same thing. We will use tables of values to decide which function is appropriate. And then today, we will also write the function that is appropriate for that table. As a quick reminder of exponential equations, we have worked with exponential equations before, back in chapter 8, I believe it was. Exponential equations are of the form y equals a times b to the x power. That's what an exponential function always looks like. Some number times some other number to the x power, where that a value number is the starting value when x is 0, and the b value is the number you are multiplying by each time, meaning the common ratio that you would find from your table by doing your dividing in your table of values, in your y values. So as an example, if I had this table of values, x, y, 0, 1, 2, 3. 1, 3, 9, 27. If I have this table of values, and I divide or multiply from one y value to the next, obviously my x's are going up by 1, up by 1, up by 1. My y values are getting multiplied by 3 times 3 times 3 times 3. So I know that the number I'm multiplying by every time, my common ratio is 3, which means b equals 3. My starting value when x is 0, that's just a 1. That's nice and easy. A equals 1. So this equation would be y equals 1 times 3 to the x. Okay, it's as simple as that with exponential equations. Find your common difference, that's your b value. Find your starting point when x equals 0, that's your a value. All right, another quick reminder about linear equations, which we should all have seen before. Most often they are written in this form, y equals mx plus b. We should be familiar with that form of a linear equation. M is the slope, the common difference that you find in your table from you doing your subtracting. And b is the starting y value when x equals 0. So, again, for example, if I have x, y, 0, 1, 2, 3, and I have 50, 57, 64, 71. Those y values have a common difference instead of a common ratio. Their common difference, as x goes up 1, y goes up 7, which means my m number is a positive 7. I don't even really need the plus, but I'll put it there anyway. My slope is my common difference in my y values, which in this case is 7. My b value is, when x is 0, what is my y value? It is 50. So I start at 50. Okay, now I know it's confusing because in linear equations, the b value is my starting point. In exponentials, the b value is the multiplier. You'll just have to get used to that. So this equation here would be y equals 7x plus 50. We'd be done. Okay. Now, one important point before we get into the meat of this problem that we're being asked to do today is that real-world data, which is what we'll be dealing with, real stuff, very seldom fall exactly into one of these patterns. Exactly meaning they have exactly the same ratio, exactly the same difference, and so on. However, we can determine which type of function is the best possible model for the data, and then we can write that equation. Okay, so we're going to decide which one is the best None of them probably will be perfect. But if you have, for example, in an exponential, if you have a ratio that's hovering right around the same amount, and maybe it's all multiplied by almost 2, like 1.8, 1.9, 2, 2.1, something like that, that can be exponential. If you have a difference that's all hovering right around the same amount, like it goes up by 50, and then it goes up by 48, and then it goes up by 53, and then it goes up by 51. If it's hovering right around that 50, you can use a linear function to approximate. Okay? So just take notice of what your y values are doing and what it is closest to modeling. Now, let's get into this example problem here. They give us a table of data at the right. They give the value of a used car over a number of years. So the number of years that it's been out, that it's been being driven. Which type of function best models this data? Write an equation for that model for this data. So I have put my table of values here, so I have some space to work. And I'm going to look at my y values, which really is value in dollars. Because my years are just going up by 1, up by 1, up by 1, up by 1. Okay? My values of these cars, if I go from year 0 to year 1, I drop by $1,510. From year 1 to year 2, I drop by $1,315. From year 2 to year 3, I drop by $1,230. And from year 3 to year 4, I drop by $980. Those differences are not the same. They're not even really close to the same. They keep getting less and less as I go on. So I do not think this is a linear function at all. So we're not going to deal with a linear function. Let's try exponential function. You'll find that all of your homework is either linear or exponential. I will not ask you to write quadratics. Let's make sure that we can use an exponential here then for our common ratios. So if I take a calculator and divide year 1 by year 2, or the other way around, I'll do year 1 divided by year 2 going back this way. That's what most of you do, I believe. 11,065 divided by 12,575. I get 0.8799. If I go year 2 back to year 1, 9750 divided by 11,065, I get 0.8811. If I go from year 3 back to year 2, 8520 divided by 9750, I get 0.8738. And then from year 3 to year 4, or year 4 back to year 3, I get 8850. Good? Now, those are not exactly the same ratio, but what I want you to notice is that 2 of them are slightly below 0.88, 2 of them are slightly above 0.88. So I'm going to use 0.88 as my ratio because all of those are very close to it. 2 on the top, 2 on the bottom. They're all hovering right around there, so I'm going to use 0.88. And in my common ratio, meaning an exponential function, this will be my b value, what I'm multiplying by each time. My a value is what I start with at 0 years, so that's 12,575. So my function here is y equals 12,575 times 0.88 to the x. That is a good approximation for that data. I can use it to get approximations for other years. Now, if you have questions about anything in that process, please make a note to ask me in class tomorrow. But the first part of the process is the same. Look at your differences, look at your ratios, decide would this be better as a linear, better as an exponential. Like I said, I won't give you any that are quadratic. And then you can write that equation using an a and b value or a slope and a b value and so on. I would like you to try this problem. Theater company's income over a certain number of years. I want you to find a good function that models that data, decide if it's linear or exponential, and then you can solve, write that linear or exponential function for this data. So pause the video, take a look at this problem, and then come on back and I will show you what your answer should be. There should be a linear function. My differences hover somewhere around 480, 476, 485, 480, 480. So I'm going to use 480 as my slope. Y equals 480 x plus my starting value of 18,254. If you have questions, please make a note to ask me in class tomorrow. That's all I have for you today. Have a wonderful night.